Hey guys, so this is the first video of the general physics section. So here we'll be talking about physics in the everyday life, like where it is being applied. There wouldn't be any derivations in mathematics. It's just logic and we'll be seeing how we can make use of it. So today we'll talk about two things, and the first thing is the use of physics and mechanics in construction, in infrastructure, in skyscrapers. And the second one is about the physics behind the working of an aeroplane. So let's start with the skyscrapers. So skyscrapers are just generally very tall buildings. They are above 100 meters plus tall. So let's see how it has an influence on physics. So let's consider this really tall building, which is 100 meters in height. So it's not so easy to construct such a building because of more the height, more is the instability. So just imagine stacking up seven books of this much height and another of just 2 books. In these both cases, if you give a push on the top book over here and the same amount of force in this book over here, which do you think would fall down more easily? It's obviously going to be this, because more the height, more is the instability. So let's see how buildings can avoid this unexpected damage. So the main concept behind this is the center of mass. As long as the center of mass of any body lies within the range of that body, there's not going to be any toppling. So if you see a person and you assume his center of mass to be within his body, he's going to be stable. But when he bends forward, his center of mass also comes forward. So as he comes more and more forward, the center of mass is finally going to be outside his body. And that is when he topples down. So that is exactly the same case with buildings. The center of mass of a building ideally is supposed to lie within the building. But when a wind flows through the building, it can cause oscillations of the building's entire shape. So the building can get tilted by even this amount. So if by chance the center of mass lies outside the building, it can cause damage. It can just cause the entire collapse of the building. So one way that this is avoided is by constructing a building by having extra weight supporting the building underground. So there's a lot portion over here filled with entire concrete attached to this building. So what is the purpose of this? Is it lowers its center of mass even underground. So now ideally the center of mass is just the center of a height if you talk about a uniform building. But now since there is more mass at the bottom, the center of mass shifts from here to underground. So when the center of mass is underground, no amount of turbulence on the top ideally is supposed to topple down the building. So even if you apply a force, the building would just oscillate among this fixed point and return back to its original position unless the force is too great. So this is one of the methods by which buildings can prevent break. So then you talk about the shape of the building. Let's assume 2 different types of building. One in which the face of the building is rectangular. This is the place from where the wind is striking. Another building in which the building is slightly cylindrical in shape, and again the force is striking the wind. So in which of these 2 buildings do you think the force is going to be higher on the surface? So the force is definitely going to be higher. Okay, let's make an assumption that the diameter of the building is same as the diameter of the cylindrical building. So the force is going to be much greater over here because the surface area is greater in the building's rectangular face than compared to a cylindrical face where it just diverges. When the wind strikes on the building, it diverges around the building attacking on only one line at a point, and this is called the tangent of the building. So the force is going to be significantly lower in a cylindrical building. So that is why most of the skyscrapers always have curved edges rather than fixed rectangular sharp edges. Okay, so next we'll talk about oscillations of these buildings. So when you're high up in the building, you usually feel dizzy, and this dizziness is not because of low of oxygen. It does not have a significant effect because the entire building is ventilated, and then it's not because of the height. It is because of the oscillations that the building is undergoing. You might not notice it because it's very low in amplitude, but then the oscillations are still taking place. The building will pivot among its fixed point and go under oscillations, froth and back. So this causes dizziness. So how do buildings avoid these oscillations? And it's the most unexpected answer you would be thinking about, and it's by using water tanks and swimming pools. Yes. So let's see how it works. Let's say you have a swimming pool that's over here. The swimming pool is free to move. Let's say the swimming pool has wheels attached over here, and you have water filled up to this much. This is the water surface. So what I'm going to do is I'm going to push this container to the right side with a force F1. Okay? So when this moves to the right side, what's going to happen is, due to inertia, the water would tend to stay at its own place. That is Newton's first law, right? When an object is in its state of motion or rest, it continues to stay in that motion. So this water would like to stay in its own position. So what happens is, you're trying to fix the water over here and you're trying to move the container to the right. That would cause the water to accumulate on the left, isn't it? So this water would then will look like this. When this is being moved to the right, the water would look like this. The water would just accumulate on the left. This causes a force to the left by the water. So this force is opposite to this force, and the effect is reduced. The total force is very reduced. So this is exactly what happens to prevent oscillations in a skyscraper. So let the skyscraper be over here, and let's keep the water tank or the swimming pool over here. When a wind flows on the building, it moves the building to the right. It's supposed to move the building to the right. But however, we saw that the swimming pool exerts a motion in the opposite direction. So the same force is acting over here, which is F1. But the swimming pool gives a force back, F2. This reduces the oscillation. This reduces the force being acted on the building. So when the wind is trying to push the building to the right, the swimming pool is trying to push the building to the left. You might think this is very negligible, but then it makes a big difference because of the height the building has. So this is just basically torque. Torque is the rotational force. A force acting on a linear body is called a force, but a force acting on a body that has the ability to rotate or oscillate among a point is known as torque. So consider the body is fixed. So the formula for torque is defined as the force you apply times the distance between the point where the force is applied and the point where it can rotate about. So it's F into R. It's actually F cross R, that is RF sine theta. But we don't need that here. We just need the force and the radius, which is the distance. So if the same force of wind is applied over here, this distance is R. So the force is going to be very less. That's why you don't feel oscillations at the lower parts of the building. But this same force magnitude, if it's applied over here, this is a greater value of R. So the torque is going to be higher. So when the force is higher, the body can oscillate more freely. That is why you feel the significant effect on the top. And the same logic applies to the water body. This force, even though being very less in magnitude, when multiplied by this entire distance becomes significant. So unexpectedly, swimming pools are being used to counteract force. So these are the basic physics involved in the infrastructure of skyscrapers. You might have not known a lot of these, you might have known, but it's definitely useful knowledge. So next let's talk about the airplanes. Every one of us have traveled by airplanes. So let me ask the first question, that is, why do airplanes have to proceed at such high speed before having to take off? Like most of us are familiar with the concepts of rockets, and you know by Newton's third law that every force has an equal and opposite force. So when a rocket is propelling thrust to the bottom, it produces a force on the top, and that is the way in which airplanes also work. So let's first see the basic principle of how a kite flies, and then the same logic can be applied to how an aeroplane is able to lift up. So this is the ground, and there's a person over here who's letting a kite. So what actually happens is the wind flows in this direction, gets bounced off by the kite, which is tilted at an angle. So it bounces off and comes down. This force that is being pushed downwards, this stream of air, creates an opposite force in the upward direction. This force, F, is what makes the kite float up in the air. So this is the principle of Newton's third law. Every force has an equal and opposite force. So that's exactly how an even airplane generates thrust. So let's consider the wings of an airplane. It's called the airfoil. The airfoil has two different types of shapes. It can be either symmetric or asymmetric. A symmetric one would look like this, and an asymmetric one would look like this. So which one of these do you think is better for an airplane? Like, just try to recollect the idea about the kite and tell me which one would be better, which one would give a higher thrust, higher lift to the plane. And it is this one, because let's see how when air gushes through the surface is reflected. When air flows through a symmetric airfoil, the streamlines of air just bend forward like this. You see that there is no significant accumulation of air at any point. It's just symmetric about every point. So if you have a certain amount of air pressure over here, the same amount of air pressure is present over here. This is the problem with symmetry. So both of these cancel out and there's no net effect of thrust. But now let's consider the asymmetric one. The presence of an asymmetric foil generates more number of lines at the bottom than at the top. So the air pressure at the bottom is going to be more than the air pressure at the top. So when the pressure is more over here than here, it tends to lift the plane up. That is pressure A greater than pressure B. So this is what produces lift. So more the lift is depending upon how the airfoil has been tilted. If you tilt the airfoil, there's going to be higher pressure at the bottom. So a tilted airfoil is going to look like this, with the air striking forward. So now the air gets reflected much stronger than in the earlier case, producing a net thrust in the upward direction. And this is what lifts an aeroplane up. So now the question, why do airplanes have to proceed at such high speeds for this to happen? It's because of momentum. The law of conservation of momentum states that momentum before the collision of any particle is equal to the momentum after the collision. So if momentum is just the physical representation of how much force can be imparted. So momentum is mass times the velocity. So let's just ignore mass because it's air and we'll call it density instead. So the density is a constant for air and the only thing that matters is the velocity. So if air comes and imparts with a higher velocity, it's going to generate more momentum and more thrust. So more the thrust at this point, more is the force that is going to come in this direction, and hence more is the force that is going to be produced in the uplift. So faster you proceed, faster the air is going to strike on the airfoils and more the force is generated. So I think now you can answer the question, can airplanes take off on the moon? what if I'm giving you infinite amount of energy for the airplane? You can proceed at like any speed you want, like double or triple the speed of what our airplanes can go right now, and you have an infinitely long runway on the moon. Can you take off? The answer is no, because there is no atmosphere in the moon. And when there is no atmosphere, you can't generate thrust by pushing the air downwards. There is no air molecules to be acted upon. The momentum is zero. So that's why you can't take off on the moon unless you have thrust produced due to gas, and that's how rockets work. Rockets do not rely on air molecules like how airplanes does. Rockets have gas which they combust to eject the exhaust. And when doing so, it produces the same principle as what we have discussed. When the exhaust is being pushed out, it creates a force. And this is going to create a force in the upward direction, and that's how rockets also work. So we have learned about two things today, right? That is skyscrapers and airplanes. There are a lot more like this. Physics is everywhere. So we'll see more of these episodes. Thank you.